Alrighty, our last video of Chapter 7, 7.4, the sum of the exterior angles. And once again, we got Teeter in the house. Miss Teeter, how are you?
Hello.
She has turned British. Alright, let's do this. So we've already briefly talked about exterior angles in the last video, but just as a quick recap, in case you're just throwing it in here because you don't remember it, our exterior angles, angle 4 here would be considered an exterior angle. Cool. It's on the outside of whatever polygon we're talking about, whether it's a triangle, a quadrilateral, pentagon, you name it. All right, it's on the outside there. Cool. So the sum of an interior and an exterior angle, interior and an exterior, is going to be 180. Right? They are supplementary angles, 3 and 4. 3 is an interior, 4 is an exterior. They add up to 180. And how many exterior angles are in a heptagon? Well, how many sides does a heptagon have? 7. So there are 7 exterior angles, 7 interior angles, 7 sides. It all matches up. How lovely is that? So once again, we already talked about the sum of the exterior angles. So rather than discovering it again, because that's not really a discovery, that's like being the second person to discover America, right? Nobody celebrates that. Wait, was Columbus second? I think Columbus was second, so apparently we do celebrate that. Anyways, because we're named America, and I think there was an explorer named something America. That's why it was named that.
Americus?
Americus, I believe, is his name. His first name was United. His middle name was States. Anyways, 360 degrees is the sum of the exterior angles of any polygon. All right? And we will mainly deal with regular polygons. All right, so the sum of the exterior angles is 360. Boom. And then we have it's S sub E, but apparently this old font wasn't able to do a subscript. And then we got our exterior angle. One exterior angle is 360 divided by the number of sides, or number of angles, right? Sides and angles, same amount. Cool. One last formula for the chapter, and that is the diagonals. Okay? The number of diagonals, n still being the number of sides. So, let's talk about a triangle. Can I draw any diagonals in a triangle from one vertex to another vertex going through the middle of the triangle? No, I can't. How many sides does the triangle have? 3. So I'd have 3 times 3 minus 3 over 2. Well, 3 minus 3 is 0. 0 times anything is 0. 0 divided by anything is 0. 0 diagonals. Wah, wah. How about a quadrilateral? Well, let's see here. By our formula, we should get 4 times 4 minus 3 over 2. Well, what's 4 minus 3? That's 1. Times 4 is 4. Divided by 2 is 2. We should have 2 diagonals. When I draw them in, boom. So it's a little different than when we were dividing these up into triangles. Diagonals are just from one vertex to another, as many as you possibly can. Okay? And the same would hold for a pentagon, a hexagon, so on and so forth. This formula right here, and you will be expected to know this formula along with your other ones. So commit them to memory, children. All right, a few quick examples. Find the sum of the exterior angles of a convex heptagon. A convex just means it's like a normal looking heptagon. Okay, it's not necessarily regular. Convex versus concave. So convex will look something like, oh, my pen's not writing. Here we go. 3, 4, 5, 6, 7. So there's 7 sides. That's convex. Concave is like it has been dented in. So that's let's see, 1, 2, 3, 4, 5, 6, 7. That's a concave. Okay, it looks like it fell on one of its vertices and then it got pushed in. Alrighty, we're mainly going to deal with convex. So what's the sum of those exterior angles? All of them will be 360. Yay! All right, what is the measure of an exterior angle of an equilateral, or sorry, equiangular, which is also equilateral, heptagon? Well, how many sides does a heptagon have? 7. If you remembered your names of all these, which you need to remember, because that's so important to your rest of your life. You're going to be in a job interview, they'll be like, hey man, you guys, you're just great, but how many sides does a heptagon have? And you'll be like, I know that, it's 7. Boom, you got the job, see? So we'll do 360 divided by 7. And we pop that in our calculator. This is not a nice number. It is 51.428, so 0.43. That's how many degrees each exterior angle is of that equiangular heptagon. All right, here we got, if the measure of an exterior angle of a regular polygon is 15, how many sides does the polygon have? Well, the number of exterior angles is the same as the number of sides, correct? So if all of my angles should add up to 360 and each one is 15, what could I do with them numbers there? Well, if I divide this by 15, I've got 24 angles, which is 24 sides. Boom! How lovely was that? And this just goes to show you how easy this formula is to work with compared to the interior angles that we addressed yesterday, and I brought up exterior angles. So if we had 15 for an exterior, my interior would end up being 165, right? And I give you the same problem and say the interior is 165. How many sides does it have? Well, figuring out your exterior of 15 would make this problem a lot easier than working with that interior angle formula. So, super useful formula to use on many occasions, many special occasions of math. All right, find the measure of each interior and exterior angle of a dodecagon. Well, how many sides does a dodecagon have? Well, decagon's 10, do, 2, 1, 2, 12. Boom. America. All right, so I got 12 sides. Well, interior and exterior angles. I like to draw out like a partial polygon when I'm doing this, and then I throw in my extended side. That's my exterior. This is my interior angle right here. Well, if I've got 12 sides, 12 angles, both interior, 12 exterior, right? If I did 360 over 12, what's that going to give me? Well, that will give me 30, which is my measure of my exterior. And if 30 is my exterior, what's the supplement of that? 150 is my interior. Woo! We're cruising, ladies and gentlemen. We are cruising at a high rate of speed here through math. Hopefully Officer Gregorio doesn't pop by and write us a ticket for going so fast. You guys can handle it, though. All right. What is the name of an equiangular polygon if the ratio of the measure of an interior angle to the measure of an exterior angle is 3 to 1? Man, we haven't seen any of these wonderful ratios in a long time. I'm going to draw a partial polygon that I don't know how many sides it has. I'm going to extend that exterior. So my interior to the exterior is 3 to 1. So 3x to 1x. That's what I like to do. I like to add those x's in there so I can set up a wonderful equation. Well, what do I know about my interior and my exterior angles? They add up to 180. So I'll be having 4x equals 180. If I divide 180 by 4, I get x equals 45. So that's what I have, right? It says, what is the name of the of an equiangular polygon if the ratio of the measure of an interior to an exterior is 3 to 1. So this is my measure of my what angle? Well, since x is 45, my exterior angle would also be 45, right? My interior is going to be 135. But my exterior is easier to work with anyways. If I just take my sum of my exteriors, which is always 360, and I divide it by 45, I will get my number of sides, which will be 8. Now, if I just said 8 for my answer, I'd be incorrect because it says, what's the name? And the name of this wonderful, wonderful polygon with 8 sides is an octagon. Excellent. Wow, that was so much fun. So that's my final answer. If you just wrote down 8, you lose a point. We don't want to do that. We love points. Points are unfortunately what motivate you children. I wish it was the learning. Maybe it's the learning. It'll become the learning, children. In time, you'll be motivated by the learn. All right, last problem. A polygon has 54 diagonals. How many sides does it have? My goodness, Mr. Allen, you just gave us this wonderful formula for diagonals, yet now you're asking me to do crazy things. All right, so diagonals equals n times n minus 3 all over 2. Okay. Well, I know the diagonals are 54, right? So that's D. It'd be so easy for me to just say, hey, it has 10 sides. How many diagonals? We're not here for easy, children. We're here for a challenge, right? So that equals n times n minus 3 over 2. How am I going to solve for n? Well, I'm going to start by multiplying by 2. Get rid of this fraction, you know what I'm saying? So it's 108 equals n times n minus 3. So that's what? N squared minus 3n. Oh my goodness, I have a squared term. Factor. My favorite F word, Miss Teeter, is factor. I'm going to subtract 108 from both sides. And now I get to do this awesome thing called factoring to solve. I have 0 equals n squared minus 3n minus 108. So what two numbers multiply to 108 and add to 3? My goodness, 108 is a large number. I need to figure this out ASAP. All right, so I did some multiplying, and it was my first guess. 9 and 12. 12, 9. Which one's negative? The 12, because we want it to be a negative 3 when we add them together. So I get 12 sides or negative 9 sides. Miss Teeter, do you think that something could have negative 9 sides? What? No way. Do you know Miss Teeter's favorite F word is?
Facetious.
Facetious. That's a fun one, you know. Mine's factor, hers is facetious. We got 12 sides. That is wonderful. Now, I wonder if we answered the question. I can't even remember what it was. It says a polygon has 54 diagonals. How many sides does it have? Then 12 would be my answer. If I asked you for the name, like I was a crazy dude and I was like, hey man, what's the name of this? It would be a dodecagon. And I did write this with some capitals and some lowercase because I don't know what I was thinking. All right. Dodecagon, though, if it asked for the name, but it only asked for the sides, we're good to go. Rock and roll.